Hi, this is my paper in collaboration with Rajesh V. Raghavan at Georgetown. Field workers are necessary for AI projects in low resource areas where there are limited data sets available. It is standard procedure in building AI in low resource areas to partner with field organizations and their workers like community health workers and agricultural extension workers. These workers play a crucial role in the bootstrapping as well as in the deployment of AI models. Field workers are known to be underpaid and overworked. For example, an ASHA worker, a community health worker in India, performs a mind-boggling array of 720 tasks, and AI data collection is often additional to their primary responsibilities. Domain experts like the field worker are chronically undervalued in the history of AI. Here's an illustrative quote from NLP researcher Frederick Jelinek on the disregard for domain experts in language models. Every time I fire a linguist, the performance of the speech recognizer goes up. Given that models seek to emulate and aggregate local expertise from field workers, to what extent is the worker's expertise acknowledged, engaged with, or credited by the AI developer in building the model? To answer this question, we studied up AI practitioners building cutting-edge, high-stakes AI systems in low-resource areas. We report from 68 semi-structured interviews with AI practitioners working in high-stakes areas in the US, India, and various sub-Saharan African countries. More details on method in the paper. Our results show that despite the mastery and the tacit knowledge of field workers, that takes decades to build, and that which the AI model seeks to emulate, developers seem to reduce field workers to data collectors for their uber expert models. We find that most developers do not have any first-hand contact with, provide training to, or compensate field workers for their data labor. With the absence of direct interactions with workers in most cases, the work of a field worker was primarily read through their dataset artifacts. AI developers attributed poor data quality to poor work practices of field workers. Workers were typically perceived to come in the way of worthwhile model development efforts of developers. We present 4 conceptions of field workers as held by developers in the paper: field workers as corrupt, lazy, non-compliant, and as the data set itself that is referred to as outcomes and outputs and not as human beings. Despite the limited engagement and understanding of field workers, developers reported creating several disciplinary interventions in the form of algorithmic fixes to influence field workers to collect better quality data in the form of surveillance, gamification, cross-verification, and pre-processing. To borrow from political anthropologist James Ferguson, data collection in AI operates as an anti-politics machine, making political decisions about what constitutes expertise and creating technical solutions to technical problems through management interventions to influence better quality data. We argue that AI development in low resource areas deskills domain experts in these contexts. Field workers should be accurately viewed as domain experts with special knowledge and mastery in their local areas. Even though the models in our study sought to emulate and improve over the expertise of workers, their expertise itself was treated as non-essential knowledge by developers. The workers' knowledge, networks, and capabilities were viewed as simply assets for dataset collection rather than necessary expertise for system building. AI developers who are experts in their technical areas, but not in application domains, for example, a developer building a cancer prediction model, will inevitably leave gaps when domain experts are excluded from the model that seeks to learn their knowledge. The data quality issue that we report here is only an issue if we think of domain experts in these limited ways. But if we were to reimagine domain expertise as an essential partnership throughout the ML pipeline, we can see new possibilities for collecting, modeling, and scaling knowledge. Domain experts can contribute to critical questions like, what exactly are we modeling? What assumptions are appropriate? What features should be included in the model? What are we trying to predict? How will we know? All of this can impact model behavior. We call for viewing domain experts as full range experts in their communities. We call for finding participatory ways to partner with domain experts in the ML lifecycle, from problem formulation to measuring impacts of the systems. We need better recognition and attribution of domain expert contributions. We discuss all this and more, and the practical details on how in the paper. How expertise is defined, who is considered an expert, how expertise fed into models is acknowledged and credited are all important questions to answer. We press upon AI developers the need to embrace more participatory stances in AI labor, not control and punishment. Instead of motivating an overworked health worker to do more work for AI data collection, one might ask how to help them achieve their goals better, how to prioritize their numerous visits, better capture of their in-situ knowledge, allocate limited medical resources better, and build visibility into their contributions. Indeed, this is one way to realize the shared goal of human development of both the domain expert and the AI developer in low resource areas. Behavioral tricks for improving data collection like gamification and surveillance will only cause long-term damage and resentment among workers. It's possible to interpret the perceptions of worker corruption that we report as acts of worker resistance to exploitative conditions of work, modifying James C. Scott's memorable phrase, "These are the weapons of the data collector." Unregulated surplus labor poses new questions on who are the contributors to AI. How should attribution, transparency, provenance, and compensation evolve to include the long chains of surplus human labor in low resource areas? Finally, economic measurements of AI, such as how a model can detect tuberculosis in 15 seconds instead of 10 days, measure the before and after effects of algorithms that are dropped into social settings. However, they miss out on measuring how domain experts and workers were involved and drafted into labor for the AI system, whether and how experts and communities were displaced as a result of the system, and whether and how expertise was redistributed in the longer term as a result of the model. We need to expand the parameters of what gets measured and seen in AI systems and include not just the model outcomes, but also the effects on the humans who are all part of the AI enterprise. Thank you.